Hello, this is Yasmin Muslim from Adapt Center, School of Computing, Dublin City University. And today I'm going to talk about our paper, Arabisc, Context-Sensitive Neural Spelling Checker. This paper has a story. Let's imagine a colleague told you they wanted to develop spelling checkers for languages that don't have readily available spelling checking APIs with high quality. However, your colleague has a problem. When they tried state-of-the-art approaches that depend on neural decoder-encoder architectures, the resulted spelling checker was prone to overcorrection, which means it would modify words in the input sentence that are actually correct. In your discussion with your colleague, you realized that traditional approaches before neural networks used to correct sentences word by word, which minimizes the overcorrection issue. However, you want to make use of the power of neural approaches. Here are some examples of overcorrection caused by using encoder-decoder architectures. Correcting words that are not really misspellings, changing the original meaning, or even introducing new misspellings. In this context, Hertel found that neural encoder-decoder models for spelling correction perform worse than neural language model-based approaches. This makes sense because language modeling offers more control through predicting word by word, given the previous history or context. So we decided to use a language model for our spelling checker. However, we got an issue. See this example. Here, the word principle is affected by both the words before and after it. In other words, it has a left context and right context. Regular language modeling cannot deal with this because it takes only the left context as input. So our solution is to use a dual input language model, which takes both the right context and the left context as inputs. Notice here that the word principle is ending with AL, and it's affected by words before it like students and words after it like supervisor and university. Now, what if our spelling checker is faced with this error in which a principle is ending with LE instead? Note that it's still a correct word, however, not in this context. So here is the algorithm of our spelling checker, and it depends on a dual input language model which checks a given input sentence word by word. And then it predicts the next word and generates a list of high-scoring candidates B, given both the left context and the right context of the current word. If the current word is not in the list, correction suggestions are offered based on the edit distance between the current word and the candidates in B. We compared our single input model and dual input model and applied enhancing techniques to our dual input model, such as lemmatization of very long words and correcting the misspelled word before predicting the next word. So as you can see in the table, for real word errors that are correct but not in the current context, our dual input model outperforms the single input model. Similarly, for non-word errors that are not correct at all, our dual input model outperforms the single input model, as well as two popular tools used for Arabic spelling correction. Finally, it's worth mentioning that while we carried out our experiments on Arabic, in theory our approaches can be applied to other languages. We shared the code, models, and data of our paper on GitHub for you to check if you like. Thank you very much.